Hello everyone and welcome to MinervaDB Athena 2020. So let me personally thank each one of you for taking time and registering for this talk, attending this conference from wherever you are. I'm sure most of you are working from the home, and and the speakers, right? We have fantastic line of speakers for MinervaDB Athena 2020, and the primary objective of MinervaDB Athena is no way different from rest of the open source conferences committees. It is to connect, it's to learn, it's to educate, share the knowledge and experiences and stories. And that's the primary objective. The original plan of MinervaDB Athena 2020 is to host a physical conference, either in San Francisco or Singapore, so that we can connect with our friends, the community members, a lot of customers. So this was the original plan. Unfortunately, the global lockdown pandemic has pulled down the plan. So with definitely a lot of support from the core community members and friends, it's like, hey, the idea seems good, like we are creating, people are spending more time at home, almost all of the time, and all the time we are at home, zero travels. These conferences are a better way to connect with our communities, and how actively we can stay in touch with our friends. So I started this initiative as MinervaDB Athena, and this is an open source, completely vendor neutral and independent open source conference. Started for now as a database systems conference, with focus on open source database systems conference, with focus on MySQL, MariaDB, PostgreSQL, columnar stores, NoSQL, and definitely included Linux talk also. I wanted to include more, but then we could manage only one Linux talk. But I'm sure you guys are going to enjoy that. As we grow further from here, the objective is that how we can have a completely full stack data performance and reliability conference. That's the objective. Uh, I want to share with you about the speakers in this conference. We have fantastic speakers. Like I said before, we have great, much sought after speakers globally are talking in MinervaDB Athena 2020. We have venture capitalists, we have business leaders, we have the core engineers, we have support ninjas, we have Linux performance experts. They're all talking. Let me introduce. Let me share with you who are they. From Sequoia Capital, they are a diamond sponsor for MinervaDB Athena 2020. We have a partner from Sequoia Capital, Anandmoy Roy Chowdhury. I call him Roy. Most of us in the open source and the startup ecosystem know him as Roy. Roy is talking about like how the venture capital ecosystem is playing a very active role to enable the open source software, pure tech, deep tech, business companies. How Sequoia supports several open source projects internally, as well as several communities, and how the future looks for an open source software entrepreneur, and how the venture capital companies can be hands-on in providing you the strategic guidance, a better market understanding, a better introduction on how you can scale your open source software enterprise, or even the project. Followed by Roy, we have Peter Zaitsev. Peter Zaitsev don't need any introduction. Peter Zaitsev of Percona. Peter is going to talk about MySQL 8 observability, which is all about how you can annotate MySQL performance in MySQL 8. And he's also going to talk about MySQL 8 histograms more in detail. Followed by that, we have Valery Krawczyk. Again, we don't need any introduction about who is Valery Krawczyk. A support ninja. Most of us contact Valery directly if there is something on we have to do on support. Valery is going to talk to us about how you can troubleshoot MySQL and MariaDB with dtrace. Also, unconventional tools how you can use to troubleshoot your database infrastructure performance. We have Federico Razzoli. Federico is going to talk to us about how you can automate your database infrastructure operations with Ansible. We have Karthik. Karthik is going to talk about how to automate the MySQL infrastructure operations with MySQL shell. Jean-Frank Hayes is going to talk about MySQL replication troubleshooting. It's very interesting. I'll tell you why. Because most of the guys who want to know about how to troubleshoot MySQL replication definitely talk to Jean. Jean, among us, Jean spent a lot of time in building MySQL for high availability, for database reliability, scale out. Followed by we have talk from Rene of Proxy SQL. If you are, I mean, like again, Rene don't need any introduction. A very long-time MySQL DBA who understand both MySQL from a database infrastructure operations professional to the creator of Proxy SQL, which is like how I can scale MySQL horizontally. It's about sharding MySQL. But then Rene this time is even talking more about what is coming new with Proxy SQL, how you can use Proxy SQL for more good, like how some of the largest corporations have used Proxy SQL, not just limited to a sharding. We have talk from Tanel Potter. Tanel is a expert in performance troubleshooting. Tanel does performance troubleshooting bottom-up approach with a bottom-up approach. Let me tell you how is that different. Unlike most of the performance engineers who use native tools to troubleshoot, interpret the database system's performance with the tools like slow query log or any of the metadata tools, like metadata dictionary tools, maybe be it on PostgreSQL or be it on MySQL or MariaDB, or auditing the transaction and coming out with that. Whereas Tanel is showing us like how he can use probes, the Linux probes, which can be used to troubleshoot the performance from an infrastructure perspective. Right from interpreting how the threads are performing to how the application response time look like, how the throughput is like, how the infrastructure is used by the underlying application. And who else? I think I mentioned most of the names. I have Krunal Bosker again. Krunal is an expert in a MySQL ecosystem, a very respected MySQL engineer, a good friend of mine. Like each one of mine is a very good friend of mine. Like yeah, but then Krunal is going to talk about open source database systems performance on ARM, and we have a speaker from Galera cluster. Again, no introduction needed. It's Colin Charles. So Colin is talking about like how Galera cluster is now looking for WEBSCALE, how you can use Galera cluster for better replication performance, even long distance replication performance. Interestingly, Colin is talking to us about what is the missing direction in most of the Galera cluster infrastructure administration. So in all, right? It's going to be a great experience. I'm sure you're going to enjoy this conversation, the talk. We are doing live streaming. In the entire event, will be a live stream from 9 a.m. Pacific time on 11th of December, Friday. That's tomorrow. So by this time, yeah, like we will be almost 30%, 40% by this time. Yeah. So So I'm talking just a day before, just to make sure that like all the speakers are in line, the content is line because so okay. So we are excited. I'm talking about building database infrastructure operations for WebScale, how you can build an optimal and reliable database infrastructure operations. This time, I'm not talking about any specific database systems stack. I'm not talking about, my talk is not going to be a MySQL talk. My talk is not going to be a MariaDB talk. My talk is not going to be a PostgreSQL talk. But then it's going to be about how you can use an open source database systems for infrastructure for performance and reliability. So I hope you guys enjoy the conversation. We have a public group for on Slack for this MinervaDB Athena 2020. Our speakers will be there most of the time. Our speakers are happy to help you. It's that they've been supporting the community quite extensively for more than most of them are like approximately 2 decades of experience in this open source ecosystem. Yeah. So feel free to contact us for anything about the conversation. Be active on the Slack channel. Enjoy this event, and thank you for registering and making this event. Um, I don't call it great success. I call it like it's a great feeling that like I could connect back with the community in this lockdown time. Um, to conclude on this video conversation of mine with everyone who is attending this conference, wishing you a very happy and Merry Christmas in advance, a fantastic 2021, Happy New Year in advance, a much better 2021 where we can move out freely, can travel, meet in person, and have a lot of fun. Thanks, guys. So enjoy MinervaDB Athena 2020. Hello, everyone, and welcome to MinervaDB Athena 2020. Um, Thank you all for registering for this conference. Personally, want to thank each one of the attendees and committee members and other speakers who made it this happen. So, what am I going to talk for MinervaDB Athena 2020? So, my talk is going to be about what it takes to build database systems infrastructure for performance and reliability. So, this time my talk is going to be different from my usual very tech focused. Either it will be MySQL or MariaDB focused talk. This time I'm not talking about specific to any database systems tech stack. So it's going to be a functional database systems architecture talk from me. A quick bio of me. I'm an open source database systems guy for last 17 years, focused on building systems for performance and reliability. Work for some of the largest internet properties like PayPal, AOL, Yahoo Japan, and Nike and Garmin, a few of them. And currently, I'm the founder and principal of MinervaDB. We are a full stack open source database systems company addressing performance, scalability, and database reliability engineering. Also include my contacts, so you can always contact me when needed. All right, let me do a quick introduction of MinervaDB Athena 2020. So this is a vendor-neutral and independent open source database systems infrastructure operations virtual conference hosted by MinervaDB. The original plan was never a virtual conference. The original plan was create a conference hosted by MinervaDB. Unfortunately, due to this global pandemic and lockdown, we decided this year we're going to be a virtual conference. The topics are going to be the performance, scalability, the architecture and internals for data SREs, and how you can build database infrastructure for WEBSCALE with automation, and the tricks and trades of production engineering and the real life stories. For now, the technology focus of this conference is MySQL, MariaDB, PostgreSQL, columnar stores like ClickHouse, NoSQL, and Linux. Speakers, we have fantastic speakers for MinervaDB Athena 2020. our speakers are from diversified background and experience, expertise, and interest. So I'm very sure it's not going to be the tech talks are never boring, but I'm saying that you'll find a great connection with people who are the business leaders in this ecosystem, people who support this ecosystem, people who engineer this ecosystem to scale gracefully for planet scale internet properties. Also, the people who build these ventures, like how the venture capital companies look at creating open source software projects, how they use for their portfolio companies, and how the business is seeing open source projects. So we have great speakers for this event. Like we have speakers like as I said, right? We have very varied interest conference speakers. We have Anandmoy Roy Chowdhury. I call him Roy. He's known as Roy to most of the startups, almost all the startups. He's from Sequoia Capital. He's going to talk to us about the role of venture capital companies in building the database systems companies, open source database systems project, deep tech business, and how Sequoia Capital work with several of the startups globally. Followed by, we have talk coming from Valery Krawczyk. Valery is going to talk to us about how you can troubleshoot MySQL performance with dynamic tracing on Linux. The next talk is from Peter Zaitsev. Peter Zaitsev is going to talk to us about MySQL 8 observability, MySQL 8 histograms, how you can troubleshoot MySQL performance more intuitively. Followed by Karthik of MyDB Ops. Karthik is talking to us about MySQL shell for database engineers. He's going to talk to us about automation of MySQL ops with MySQL shells. And he's also sharing with us some of his customer success stories on MySQL shell. The next is Rene from ProxySQL. Rene is going to talk to us about the ProxySQL new features, the ProxySQL for performance and for sharding and for ProxySQL for security. And this time he's going to talk to us about some of not so popular but quite powerful, useful ProxySQL features. Also, he's sharing with us the customer success stories using ProxySQL in their business. Then Tanel Potter. Tanel Potter is a performance engineer, elite class performance engineer, I'll call it like that, because he has more than 2 decades of experience in troubleshooting performance across database system stack and Linux. He's going to talk to us about the Linux probes he used in troubleshooting the performance. Then Federico Razzoli. Federico Razzoli is going to talk to us about automating MySQL and MariaDB infrastructure with Ansible. Again, he's sharing about how he and his team at Database has helped some of the customers in automating their most complex database infrastructure configuration, MySQL MariaDB configuration with Ansible. Krunal is going to talk to us about how the open source database systems are gaining traction on ARM technically. The next is from Jean Francois. Jean Francois is talking to us about MySQL replication troubleshooting. Again, MySQL replication ninja. And finally, Colin Charles from Galera Cluster is talking to us about Galera Cluster 4 new features, how we can use Galera Cluster 4 for performance, also on long distance synchronous replication with Galera Cluster, or what are the most common mistakes using Galera Cluster, and how you can tune Galera Cluster for your synchronous replication solutions. Okay, coming back to my talk. My talk, like I said, right, this time my talk is going to be completely functional um, talk connected with the technical components. So let me tell you why. Okay, so why this time? My talk is different from my usual talk, which will be very core on MySQL or MariaDB performance. Over some period of time, when I started working very close with customers, I've noticed a difference in the trend. Maybe 7 years back, 8 years back, when I go to a customer, either they will be completely MySQL, or they'll be completely MariaDB, or they will be completely PostgreSQL. Today, I can see they have the customer database infrastructure is getting more heterogeneous. When I say heterogeneous, they have different open source database systems ecosystem in their in the business. They have MySQL, they have MariaDB, they have PostgreSQL, they have MongoDB. How do you standardize the database infrastructure instead of creating several silos of XPDs? Like you have a MySQL silo, you have a MariaDB silo, you have a PostgreSQL silo, and several such one. Like how we can build a governance on database infrastructure operations. Um, this I have personally spent several hours. Like what happened like when I initially used to go only as a MySQL support company. The conversation used to be quick. What I saw a change in the pattern last 4 years. It's like when I go there, there will be the technical engineers, data ops guys from PostgreSQL. There'll be a guys coming from MongoDB. So we spend a lot of time in first defining what's going to be the process of managing this database tech stack. Um, so that there's a visibility to the data infrastructure stakeholders. They're not, again, they're not technical guys. Okay, when I say data infrastructure technical stakeholders, they're business guys, but they are the owners of data. Um, I intentionally kept this a very neutral conversation. The whole objective is like, can we have a framework to onboard each and every database systems stack on this enterprise database infrastructure operations platform? So this is what I call changing times in database systems operations. Um, the data normie is the new digital business infrastructure. Data powers economy. So if you take the list of top 10 companies globally today, right? None of them has a physical inventory. They all are digital inventories. These are gigantic database systems infrastructure, and all of them heavily depend on building. I mean, they're heavily built on redundant, distributed, fault tolerant, optimal, and secure database infrastructure. Um, take the stories like Uber. They don't own a car, or Facebook. They have no content, or be it Alibaba. They don't have any inventory. Airbnb without any real estate infrastructure. This story goes continuously. Like so, the data owners, which used to be like the DBAs and production engineers and systems operations guys 10 years back. The story has changed now. Now the data owners are a broader audience. They are business guys, they are analysts. So we need to get them on a single framework where business understand technology, technology understand business. So interestingly, this is according to IBM. The amount of data we are going to generate is going to be more than 2.5 quintillion bytes of data. That's a big number. Uh, I'm sure this is going to be a small number in the next 5 years with variables and the machine generated data with automation. So okay, so what this means to database systems geek? We have more jobs to do now. Um, now, because data drives the business, data drives decision making. In reality, it's like there is zero tolerance to performance and reliability. And the entire data infrastructure stakeholders now are accountable for capacity planning and sizing of their infrastructure. Performance, again, performance is everything, right? Imagine like if I do if I'm booking a car for in Uber now, and that's gonna be taking 20 minutes to book my car. Definitely, I mean, not even 20 minutes. Let's say it takes 3 minutes for me to book the car or finish my drive. I'm definitely going to look for alternatives. Uh, Reliability. The systems need to be self-healing and fault tolerant. We are talking about data grade. So when I tell data grade, what I really mean by that is we don't know from which data center we are getting data. Is it from a bare metal or is it from a container? It's just like a power grid. Like I'm talking to you, all of you from my home. I'm also working from home, like all of us. Like I don't know where does the power comes to my MacBook or my lights or but all I know is I'm getting power. So like that is going with the data grid. Like data should be available, should be fault tolerant, should be self-healing. Data infrastructure um, it's, should be fault tolerant. Yeah. Um, Data security is something like on my experience, right? In last 36 months, every conversation I had with a startup founder or a CTO or the technology infrastructure owners or data infrastructure owners, 20% of my conversation goes on data privacy and the statutory compliance. With fintech, with health tech, fintech, all this coming in, there's a lot of private data. There's a lot of sensitive data getting in database infrastructure. Scalable, because systems are growing on uncontrolled fashion. When I say uncontrolled, like each and every platform is today available on wearables, on mobile devices, on your browser. So yes, like the traffic is not now linearly scalable. So we need to look at like how horizontally we can scale database infrastructure. Accommodating more data. We are creating now more data. It used to be like when I was like 15 years back, it used to be like 70% of data is created by transaction processing system and 30% of data is created by analytic systems. That was something like I was reading in one of the research journal. Today, like I have several kind of data. I have transaction, I have columnar, I have eventually consistent. I have unstructured data, I have graph data, I have time series data. So if you're going to have more data, that means there is more work to be done. So we need to have a unified process to make sure that data infrastructure is working seamless and optimal. So let me start with the building capacity for it. So when I'm talking about the planet scale database infrastructure, I'm talking about the amount of data generated. So first and most important thing which comes to me like, hey, how am I going to do the capacity planning and sizing for this? Too big and too small is very scary. Too big is more scary for me. I tell you why. Um, Too small, I fail soon. That's good. Be it anything, fail soon is better than fail miserable with time. When you do a very generous sizing, right? Hey, I'm going to buy the fastest machine, the highest storage. Actually, what happens? You get more negligent. This is something like I have a super powerful car. Then that means that that gives me a confidence to drive the car without even understanding the road quality, the traffic, the city, the geography, right? Like not always everything powerful is good. If it is good, I mean everything powerful is good if it is in the right hands. So is doing business on a database infrastructure which is generously sized. Um, Super confidence, and that means like, hey, I have a very fast machine, so I'm not going to invest on a monitoring system. Or even if monitoring system is there, I'm not going to be worried about alerts. Why? Because there's not going to be any alerts. Trust me, I've heard this, right? I've heard this from several communities. Like, hey, I'm not worried about database systems now. That's there because I have a very fast computer. I have SSDs. We have a monitoring system, but then I'm not worried about the pager duties and all those things because most of them are false alarm. Um, Backups, I have a very big storage infrastructure. I'm going to retain my backup in my own database server because it's a high-end machine. It will not fail. I'm not going to worry about my SQL quality. I don't care about the SQL because I have a fastest processor. I have SSDs. I have a lot of investments on RAM, so I have very fat InnoDB buffer pool size. If you're talking about MySQL or PostgreSQL cache, right? So I'm not going to worry about that. And a lot of indexes, I don't worry about the indexes again. I have bigger infrastructure. So for everything, right? I've come across like we can afford to do a big database infrastructure, very generous schema design. The generosity never ends with your capacity. Generosity drills down to the architecture, drills down to the engineer, drills down to the maintenance operation. Now look at this. You go negligent because you have a super powerful computer. That negligence leads to super negligent architecture. That leads to careless way of looking at the SQL performance, the query performance. That leads to like unmanaged, non-maintained database infrastructure. And this all works great. Let me tell you that this all works great. Why? Because the bigger you are, when you go negligent, it takes time for you to fail. But when this fail, imagine you built a system as a single point failure system, super big iron machine, and that failed. Several times in MinervaDB support, we used to get this call, like, yeah, everything went off. And we go and see this is like, it's a huge infrastructure. And if you want to scale this infrastructure horizontally, it's going to be super expensive. And definitely, investing more on faster hardware is not the way to scale the performance. Systems which are not designed to scale will never scale. So where it all starts, it all starts with a single point of failure database instance, which is scaled vertically. And there'll be no performance benchmarking report which says like we have invested in this capacity by looking at if our business grows from now in next 6 months 10x, and for next 12 months 50x, this is going to be our infrastructure look like, and this is our benchmarking report, and this is how we have done that. That'll be missing. DR plan. This goes missing many times. Let me tell you, like I've come across many customers, the early stage, like they don't have a DR. They say like, hey, we have a logical backup. We don't worry about data now because we are in the beta stage. We are not started billing customers. Some data loss is acceptable. Look at this. When you make the foundation weak, right? You can't build anything strong on top of it. There's no backup plan. There's nothing documented, right? How are you going to back up? What's going to be your recovery checklist? Have you written all the list of failure scenarios? What's going to be the failure and how are you going to fail over that? Or what's going to be a rollback plan? If there is a data corruption, human error, corruption, what will be that? It could be a application error, it's a human error, what will be that? But then what's the rollback plan? Monitoring, right? This is something when we even look at there's a natural tendency when you start things early, right? We'll have a very generic monitoring infrastructure, which is fine. Like when you start very low. We start in a low profile. That's great. But then how is there any plan for maturity? So I'm not saying that day one you invest on a monitoring stack, the day one you invest on a DR stack. I'm not saying any of this. I'm saying that have this, right? If you move from, let's say that from 500 gigabytes to 500 gigabytes to 5 terabytes. When you grow in that phase, like 100 gigabytes to 500 gigabytes, so 500 gigabytes to 5 terabytes, so 5 terabytes to 50 terabytes. So you write down what's going to be your plan of growth and for your database infrastructure, and always document anomaly in your database systems. Why? There are high chances that you repeat the same mistake, and people keeps moving in a database systems. The attrition rates are quite higher, so people keep moving, and the cost of fixing, troubleshooting never comes down because there is no evidence of this. So, like I originally said, when the companies are growing bigger, when the database systems are getting complex, it's all about the process guidance. Why there is no compliant in the early days of database systems infrastructure? So, when you talk to a startup, right, first 2 years or first 12 months, very unlikely you hear the problem with database systems. Very unlikely. I'm not saying zero. So I'm saying very unlikely because it's like, hey, so far we're doing good at it. Why? Database systems are great in performance till the data grows. I'm putting this very vendor agnostic point, right? Be it MySQL 8 or MariaDB 10.5 or PostgreSQL 13. These open source database systems are matured with the time. They're optimized as super responsive, especially like, for example, if I'm talking about PostgreSQL 13, like it's got a parallel stream replication. That's quite good to have. More intuitive vacuuming. MySQL 8 has got now histograms, not to replace indexes, but then they can greatly influence on handling complexities with index operations. So yes, like as the database systems stack is matured, they've been more reliable. They're more tolerant. So in early days, you don't see much of the performance issues, and they also scale very well. Some data loss is acceptable, like I said, right? We are still on beta. We have not started billing our customers, so some data we can lose that. That's fine. No DBA. So what happens? Everyone is a DBA, right? Everyone creates schema. Everyone create indexes. Everyone take backup. Everyone run their SQL. And when all these things start growing, you have more application code, which is like we have more SQLs. Everyone writes SQL. There is no performance benchmarking, and then suddenly, like your complexity grows, right? The first sign of the warning, the first warning, which is ignored by many companies, right? Like, hey, there are spikes, and there is the intermittent spike happening in the database infrastructure during the complex transactions or the change in the load. That is the first sign that your system need an attention. Now, like I said, right, everyone is a DBA. Now imagine like how complex it will be to troubleshoot database infrastructure without DBA. Now, let's look at this story, right? A company with let's say 20 guys, and 20 guys, 15 guys are writing queries. They are all approved to create the indexes. They are all approved to drop indexes. And everybody is doing this. And who is accountable for that? There's nobody. And now what happens, right? If there's only one guy who does mistake, you can always roll back faster than there been 100 guys doing a mistake, right? Because the amount of mistakes, like, and there is no guidance. Like an engineer A don't know why index is created on a column 1, and engineer B don't know why the index is created in column 2. For each of those queries, they say like, hey, this index is not used. I'm just going ahead. I'm going to drop the index. So what happened technically is like there is no ownership for the database infrastructure. There is no infrastructure as well as for the engineering architecture. In some such cases, right? Like when it becomes, this leads to extreme chaos. In some cases, we have rebuilt the entire database infrastructure, right from the design, right from the installation, right from the everything. We rebuild the entire thing. This process is super complex, super expensive. One major thing, right? When you don't have a DBA, so what happens is like you'll have a very generic monitoring stack to troubleshoot your database system. Let me tell you that operating systems monitoring infrastructure is completely different. Operating system or network infrastructure monitoring is completely different from database infrastructure monitoring. Let me explain this with a simple example. Sometimes my CPU usage will be 100%. If it is purely from an operating system monitoring perspective, there is a spike happening to the CPU. That means that we need to invest on faster CPUs. Um, uh, so these monitoring stacks, right? Anything which you are using to troubleshoot a database system, not a database systems monitoring stack. Whatever graph, the metrics you are looking at is not the true story. It is the interpretation of the true story. So what happens if there's nothing wrong if a query uses 100%? I'm fine with it. And we as a database systems professionals will not complain that like a query using 100%, because if that query is performing optimally, for me the performance is response time. If a query performs faster using more CPUs, that's exactly what I'm expecting that query to do, because we already invested on a faster CPU. If I've invested in a faster CPU, my query is slow, but it uses only 20% of CPU, then I have double damage. The damage on the capacity, like I bought a faster CPU, still I'm not able to solve it. Another one is my actual query performance is going wrong. So this is a classic scenario that why we need a DBA to manage your database infrastructure. Now things get complex as your business grows faster. When I say your business, your database infrastructure grows faster. I use data as business, business as data, but that's how it is now. For us, it's data. For the business, it's business. So yeah. Capacity planning and sizing, because sizing reactively a database system is like changing wheels of a running car. So you begin something with mistake, and there are high chances that you're forced to carry forward that mistake, unless you're looking at like I was saying, right? We rebuilt the entire database infrastructure for some of the customers. Scaling, how are you going to scale? Like I say, systems which are not built to scale can never be scalable. Plan as early as possible. Don't create fatter schema objects. Think about how you can scale your system horizontally. Think about partition pruning logic as early as possible, because definitely that some data entities, like some schema objects, will definitely grow. Like if I'm talking from a fintech company's perspective, a fintech company's transactions table will definitely grow big. So I need to plan the archiving from the design phase. I should not be surprised and say that, hey, I didn't know that transaction phases the table is going to grow big. Of course, it will go big. If it is a metadata table, like something like say inventory of the financial products, that's not going to grow big. That'll be like maybe 10,000 is a big number there. So I'm saying that categorize, know your business, understand your data, right? Build the systems with plan for no single point of failure. Look at backups are everything. Invest for your backup. Should have a backup database infrastructure completely different from your production database infrastructure. You need definitely a time series database performance observability infrastructure to troubleshoot proactively. Think about data privacy and security policies. Invest on auditing. Auditing definitely consumes your storage, but that is okay, right? It's always good to be upfront, because it can be really bad. So this is a very complex thing, right? When your business grows, when your data grows, and then hiring and reading a DBA is very tough. So invest in always finding great DBA talent. Invest in educating your DBAs. That's great. This is something like so. Yes. Now look at it. This is completely different from how an operating system monitoring infrastructure look like, or a network infrastructure monitoring, or storage database infrastructure monitoring, storage infrastructure monitoring look like. Because I'm seeing that there is a latency, there is a CPU usage spike, but then I'm not even concerned about that. I'm looking about which are the queries are expensive for now, or maybe for 10 minutes or 15 minutes. So I'm looking at the performance purely on the query performance, on the response time. The challenge of building a optimal and reliable database system on a distributed database infrastructure is complex. Why? Because one, you need to have your replication, which should be optimized so that you have minimal or zero latency between your master, slave, or slave of its own definition, be a delayed slave or a secondary backup slave. But then end of the day, it should be like you care about performance and distributed database infrastructure as early as possible. Plan to roll back. So when your database grows both vertically and horizontally, when I say vertically, it is like if you have one single server and your database grows quite big. And when I say distributed, like you have replicated your database infrastructure and your database systems are growing faster. Plan to roll back if there is a corruption happens. Have a delayed slave. It's a very simple solution to that, actually. And like I always say, right, when you have redundant database infrastructure, replicated, distributed, so there should not be a single point of failure. You need to plan for a load balancer, which is the database systems protocol aware than a generic one. So that you're building high availability infrastructure for your database systems, which is like is going to be zero downtime of database infrastructure for the business. There'll be definitely down. I mean, there'll be database systems outages, but the business will not be aware of it, or business will not be impacted. When we put in the business works core with data, so they will be definitely aware of it, but they will not be impacted. So what do you record to troubleshoot? Record the slow queries. Monitor the indexes which are not used. Unused indexes are most painful problems to solve. They create more disk ops. They make your queries slow. They make the writes slower. They make the read even slower by misleading the optimizer. Tables with full table scan. Again, your optimal indexing strategy. your session histories, like which are the sessions have been active and what are the queries that triggered from them. Record the deadlocks and the queries casted, and the throughput. Record the throughput. So I'm not saying that don't worry about throughput. Record the throughput, the infrastructure usage by the queries from the database systems. This helps a lot when you're building a capacity for your next phase, or always plan for your capacity. So what happens when you're not worried about the database reliability? Like it's a complete destruction. It starts with customer churn. That leads to revenue loss. You violate you violate the SLAs you have with your customers and partners. So when you define the cost of database infrastructure maintenance operations, that include how do you plan for downtime? So what does that mean? When it is a downtime, means what's going to be the failover for the database infrastructure, for the application, for the business. Do you have a backup before you do this downtime? Because you need to have a backup which is recoverable. What is a failover infrastructure looks like for this database stack? Very important. Do you have a support partner, right? What if you hit a very serious bug and there is nobody in your team who understand how to build a new database system, or build a new patch, or don't know to build a new patch with a new source? So do you have a support provider? Also, like how is the operations of your database infrastructure going to look like when it is globally distributed? Also the DR policies. So when you're planning reliability, you may say initially that you have a lot of documentations to go through, but trust me, this is all one-time effort. Then you are just following this checklist. You're just onboarding the database systems you're going to introduced. So I just copied like how it looks like from a diagrammatic perspective. Phase one, it's like very simple. Um, Phase two gets complex because phase one, it's a both write and read. It's going to happen to a single database. Phase two, you're going to have um, writes to a database, and you're scaling the reads to another database. Um, in the phase three, right, it gets complex. You have a load balance, you have several database infrastructure. There are categories like primary database infrastructure, which are very active, and there's going to be secondary failover database infrastructure. There's going to be backup database infrastructure. There's going to be delayed slave. So it gets more complex. As you go, it gets more complex. But then you need to plan for the ROI of the database infrastructure growth. Why I use the ROI? The reason because it's like when you have built a larger system, the business SLA on database infrastructure operations gets very thin, very lean. Important SLA is about availability. So when it becomes multi-DC database infrastructure to manage, it becomes super complex. And then you need to have all I mentioned here. So I've added the observability there. But then yes, that's a lifeline. When you have a database systems distributed on this scale, of course you need to have an observability monitoring stack here. So yes, like the transaction awareness is very important for a database infrastructure team, because if you don't know which are going to be the tables is going to grow very fast, you can't plan to partition them. You can't plan on building a replication solution on top of it. Like many times it's like, I'm very happy with Galera cluster on synchronous replication. Yeah, this is a wonderful solution. But then there are customers who comes to us and say like, we are unhappy with Galera cluster because Galera cluster is not able to understand our scale. So when we do a deep drill, I can understand that the problem is not Galera cluster. The problem is with how they have used Galera cluster. Like if you write a super expensive, if you're writing a super expensive query, and that's going to look at more records. Let's presume that you're writing a big update with a wider range of um, record scanning, so that you end up in creating a query which freezes the entire Galera cluster. And now you can't say that Galera cluster is a problem, because it's about choosing what you need. To do that, you need to understand how it looks like. So that means like you need to have a transaction audit, which finds like, hey, how does a transaction originates, what happening to transaction, and what is the end of the life for the transaction. And about index operations, like who owns the index operations? Like there should not be everyone authorized to create an index. There should be everyone can create an index on a dev infrastructure. When it comes to production, there should be like battle tested indexes. And like I said, like there is a phase for index. Like there's a phase for data to originate, and there's a phase for data for the end of the life. When I say end of the life, it's like archiving it, or soft archiving it, not purging it. And so is for indexes. In indexes, the indexes, if they are used for a week or for a month, for a quarter, then they should also have a retirement plan of the indexes. So plan this. Who approves it, who creates it, should definitely have a retirement plan. And also, we need to justify that index is optimally used. Regular audit on indexing, like the largest indexes, most often used unused indexes, the indexes which creates maximum disk IO. Like I said, right, database systems are getting smarter, right? MySQL 8 has introduced something called MySQL 8 histograms. The biggest advantage of using a MySQL histogram when compared to an index is that they're very less expensive, because there'll be no change to the histogram in MySQL when you manipulate the data. That is not the case when you have an index created there. And histograms influence optimizer for performance to choose a cost-efficient execution plan. In PostgreSQL 13, again, you can vacuum the indexes in parallel. This means that you have a better PostgreSQL maintenance operations. So having said that, right, when you have smarter database systems, it's also about how smartly you use them. So 9 out of 10 times, the database performance issue epicenter comes from the engineering, from the human, from a human ecosystem. Um, only very rarely we see like something there's a bug, there's an upgrade, you have to do that for this performance happen. But most often it's about human error. How do you troubleshoot? So now maintenance operations of database infrastructure involves retaining slow logs. They are the direct way of understanding which are the queries which are very expensive. And like I said, if you are defining the query performance by response time, you need slow query log. If you're using on MySQL, MariaDB, you have slow query log. We have same in PostgreSQL. You just need to enable PostgreSQL configuration parameter log, the minimum duration statement. So, but then this is my personal recommendation to many of our customers and many of our like often I talk about this to our engineers. Like when you have slow query log, configure it very carefully, right? You can get as much as data from slow query log, like the queries which are not using indexes. But then, do you really need a slow query log to find out the queries which are not using indexes? That's the question. The expensive the admin statements. So what do you want to log? It should not be a the compulsive logging disorder. Like I log everything. So what happens? I'll create a super expensive database systems to manage from a storage infrastructure perspective, which definitely leads to like, hey, something we need to disable now slow query log because it's very expensive. So with that, like I want to talk about what is the biggest concerns we are talking about today. One of the biggest concern is about the identity theft and data privacy, digital terrorism, ransomware. Um, Expect more worse to come going forward if we are not serious about protecting the data privacy and planning proactive for data security. The entire digital economy related infrastructure is going to collapse if this is not taken serious, because connected world will become a reality only if we are building secure and reliable database infrastructure. So who owns it? Who is accountable for that? Like I said, right, the stakeholders of database systems and data is gonna be quite broad. Technically, it is be like like DBAs, data architects, engineers, data engineers, and database infrastructure security experts, database SRE, production engineers. It used to be completely an infrastructure one. Like when 10 years back, when I talk about the data or information security, it's like, hey, let's the meeting room will be only the ops guys. Today, that's not the case. Today, we have compliance guys with fintech, with edtech, with fintech. We have tons of, especially the machine-generated data, right? Wearables. They all have a lot of sensitive data. Like I don't want somebody to track my run records, my bike records, and or track my route where I'm running. So it's about each one of us are quite serious about the privacy of the data and how is that managed. Everything starts from the architecture, right? The foundation, like I said, like scalable architecture makes a scalable system. So is a secure database infrastructure architecture can only make a secure database infrastructure operations. Passwords, like this sounds very simple, right? Hey, I know that the password should be complex. Password, there should be a rule enforcement. There should be a password expiry to be included. There should be policies. But then often we do the simple mistake for complex failures. Think about somebody's financial transaction is not obfuscated in a table. Like with a query, a DBA or engineer or anybody, SQL is equally as possible, is equally as popular as English, right? So Um, Anyone can today get in SQL, and if someone get the entire spend patterns um, of people in a table that is not obfuscated, this can pull down the whole ecosystem which powers it. Like if a fintech which is not obfuscated the transaction, which will pull down the entire companies, related companies who depend on this fintech for their payment, right? So yes, like the policies to make database infrastructure secure for or the getting infrastructure secured for the database operations is very important, as important as performance, as important as scalability. Transaction audit, there'll be resistance. Like I face a lot of resistance when I talk the to my friends or my customers, right? I want to have a transaction audit. So no, that consumes storage. So we can't compromise on the security, right? We need slow query logs. So this is a very very big myth, right? Supplementing audit logs with slow query logs. Yes, like there's a lot of things you find in audit log is there in slow query log. I keep um, I log all the queries. I keep my slow query log time as 0. So that means like everything is recorded, but that's not. It's about only the queries which succeeded. Do you have the queries attempts which failed? No, slow query log don't have it. So I need audit log. So audit log is more of a granular information. It definitely consumes storage, but then there's alternate solutions for that. Like we can always archive the audit logs to a columnar store, something like ClickHouse, and do analytics on top of it. So yes, the capacity sizing for a for the database infrastructure of a connected business in the future, or maybe now, is going to be big. Storage is going to be a bigger problem to solve. So we need to plan proactively in advance. About last but not the least is about the investments what we do on DR. Um, so it looks like it's my I'm getting almost nearer to my end of my talk, but I'm not saying DR because the last topic, not because it's not so important. That's a lifeline. Things which can go wrong, can crash, will crash one day. And when it crash, if you don't have a method to roll back, it's about a serious destruction. So what's going to be the backup policy? What's the approved, and the backup policies need to be when I say audit the policy and update the policy, right? I tell you an interesting story. There's a customer which I personally started working for 6 years back. They have been like they were only a MySQL shop, MySQL database shop. Their backup works great. Percona Extra Backup. Right? Thanks to Percona, they have made a lot of fantastic tools. Yeah, that's a different thing. It was their backup works great, and with the time they started adding MariaDB. They started adding PostgreSQL. They started adding MongoDB, and the backup DR policies which has been documented approved was 6 years old, and that wasn't updated because one because of several operational reasons, because there was no guidance or the statutory policy for database infrastructure operations. So what happened during unfortunate day of crash, which crashed the entire PostgreSQL? There was no backup to restore. That was there have been weeks spent to restore with the logs, and it was quite tedious to do that. Why? Because if you really look at if you don't review your DR policies document and update it, and even if there is nothing to update, just open it every 4 weeks, every 6 weeks, and say that something, our DR policy is not going to be updated this date. Last update date is like X, and now it is Y, and there's nothing added new. So yeah, there is no update. So if that's not there, you have a system which is being DR is like a life insurance, right? It's like I have 6 members in my family, and that become 10, and I have not added the recent 4 guys to my insurance. Unfortunately, if they fall sick, they are not covered. So is the database systems, right? When you increase your database systems footprint, make sure that you go back, you look at each and every of these guidances. Like I'm talking now about data reliability, about DR. Include what's going to be the DR policy for MariaDB. If MariaDB with RacksDB, what's going to be the DR policy? And if it's going to be Percona XtraDB cluster, what's going to be the DR policy? It's going to be MySQL GA, what's going to be it's going to be PostgreSQL. So is like as you have multiple heterogeneous database infrastructure in your system, plan DR also. And then what's going to be your data outage scenarios? What are going to be the data outage scenarios? How are they going to be fixed? Record the history. How was that outage? What was an epicenter, and how it's been fixed? Also, like most frequent data outage scenarios, like accidental drop of a database, accidental drop of a table, a bad query went and deleted all the records so how can I roll back? Or what's going to be my restoration? The unsuccessful backup, so like how that is addressed. When was validated? When was the backup validated? What was the size of the infrastructure where we validated backup? What is the time to restore? Because the SLAs evolve from the policies. So let's say the business keeps an SLA of like time to recover a terabyte of database is going to be 10 minutes. Because it's not been communicated to business that, hey, you know something, our policy very clearly says that a terabyte of database restoration is going to take 4 hours. So these are the mistakes. These are the functional architecture mistake for a database infrastructure maintenance overhaul, right? That creates the chaos. Archiving policy of backup purging. So who is going to audit it? So when you streamline the entire process and automate it, however, I heavily use cron jobs for that. But if this document is being maintained, it gives a clarity. And when a new DBA comes to an ecosystem, or new data infrastructure owner comes to the ecosystem, they have a very graceful way to take the ownership without any presumption. Like this is how it works. Complexity. Yes, the things are getting very complex. We are going to have heterogeneous data platforms. Now, most of the organizations, they have transaction processing system, they have eventually consistent systems, they have columnar store exclusively built for sort search intensive queries. They have new SQL to address the best of both, addressing the best of both from eventually consistent and ACID compliance ecosystem. And again, database infrastructure is also more heterogeneous. We are on premises, we are on bare metal, we are on cloud, we are on containers. And how do we orchestrate? How do you harness the database infrastructure of future? Is like the AI will fuel the performance troubleshooting of AI, and machine learning will fuel the performance troubleshooting of very large web scale or planet scale database infrastructure proactively, intuitively. So with this, I want to make a conclusion of my talk. So my talk today is like about governance and policies in building database infrastructure, which is resilient, which is more intuitive, which is ready for AI. And you can't get into automation, you can't get into an AI for database infrastructure until we have the policies of database infrastructure operations in place. So it's now we need to do that. It's not about waiting for when the AI happens or then doing it. And your AI project won't succeed if you don't have the policies and governance guidance for database infrastructure is not in place, reviewed, approved, and frequently updated actually. Okay, and thank you so much. Thank you so much, guys. It's been great talking after some time actually. It's a great experience. Thank you so much. Thanks everyone from MinervaDB Inc., MinervaDB conference committee, Athena team, speakers, each one of you. We are hiring. If you are interested to know about who we are hiring and what's the hiring going on, please contact me. You can write to me directly. You can also visit our opportunities page and MinervaDB careers. Thank you. Thanks again.